These are the three equations that we had to explain in the previous sessions, and then we understand what each term mean, right? So we are going to use them mostly to solve questions in this section. So let's look at the first question. The first question is saying that a car starts from rest and accelerates uniformly at this 2 meters per second squared for 5 seconds. How far does it travel in that time? So we need to write the parameters, right? So you need to write down your parameter, define your parameter. So a car starts from rest. So if they say start from rest, it just means that the initial velocity, which is u, we said that this is u initial velocity, right? From rest, meaning that initial velocity is equal to 0 meters per second. That's what it means. And accelerate uniformly at 2 meters per second. So they give us acceleration a is equal to 2 meters per second squared. Now for 5 seconds. So they give us t equals to 5 seconds. Now we need to look at what are they doing. How far does it travel in that time? How far? So they are looking for like distance, right? So distance, they are looking for s. So this is what they are looking for. So we need to look for the equation that can relate all these things and right and give us something like the equation like that will relate to this. So let's go to our equations. So we were given from the this one, we are looking for s, right? We are looking for s, but then um we know u, we know a, and we know t. So where can we see this? Meaning that v is not inside. There is no v inside. So you can see that in the parameter v is not part, right? In any of the even the one they are looking for, v is not part, right? So but this is the only equation that v is not part, like we as we said. So v is not part of this equation. So we need to the higher chance of looking at this equation, right? So let's look at this equation. This equation, we are looking for this s, right? Let me change another color. So we are looking for this s. We have u, we have t, we have a, we have t, right? So we have everything. So one, two, three, four. So they are all fine in this equation. So meaning that this is the best equation to use for this. If you go to this equation, there's v, and we don't have anything on v right now. But then all these things that we are finding here are all inside this equation. So we are going to use this equation. So we go back. The equation that we are supposed to use is s is equal to ut plus half at squared, right? So s will be equal to u is what? U is 0. So 0 times t is 5. T is 5, right? Plus half times a is what? 2 times t, which is 5 squared. So 5 squared like that. Let me clean this side so that we can have this in where we're written here. Okay, so let me clean this guy too. Let's just now calculate. So s will now be equal to 0 plus, because 0 times 5 is 0, plus half times 2, that will be 1. 1 times this is going to be 25, right? So s is equal to 25. The unit will be what? This is in meters per second, right? So the if it comes to distance, we are going to use the meters. So it's going to be s is equal to 25 meters. So this is the final answer for this question. So you see how we did it. We wrote the parameters down. We went to decide on the equation that we need to use, right? Let me clean this one because we'll come back to it and come and choose the right equation. So we use that particular equation to solve it. As simple as that. Okay, let's go to another question. So we are done with this particular question, right? So we need to go to another question, which is this one. This one is saying a motorcycle is moving with an initial speed of 10 meters per second. So they give us u equals to 10 meters per second. It accelerates uniformly at 3 meters per second. So they give us acceleration is equal to 3 meters per second squared, and a time of 4 seconds. Time of 4 seconds. What is the final velocity after 4 seconds? So they are looking for v, right? Final velocity, that's what they are looking for. So we need to go to VU80. VU80. There's no s anything s over here. So we need to go to the equation where s is not part, right? So here s is part of here, s is part of here. But then um UV80, they are all found inside this equation. So that makes this equation the best to use, right? So we go back. So they are looking for v. So v is equal to u plus 80. So v is equal to, what's my u? My u is 10 plus a is 3 times 4, right? So v is equal to 10 plus 12. So v is equal to 22 meters per second, because it is velocity, so it will be meters per second. So this is the final answer for this question as well. Okay, so that's good. We find the parameters, and then the parameters will guide us to know which equation to use. They say a train is moving at 50 meters per second. So they give us, Tiga gave us u is equal to 15 meters per second, and accelerates uniformly over a distance of, so they give us s equals to 120 meters to reach a velocity of 27 meters per second. To reach, meaning that will be the final velocity, will be 27 meters per second. What is the acceleration of the train? They are looking for a, right? So you see that among all of them, it's only t that is not found. How do I know it's all of them? You just use this shortcut, SUVAT. For equation of motion, you use the SUVAT this thing. So s for the s distance, u for initial velocity, v for final velocity, a for acceleration, and t for time, right? So all the parameters that we use in the equation of motion is SUVAT. But then among all of them, for this one, for this particular question, t is not given. So, and I gave that for the each equation, right? T is not part of this one. T is not part of this one, but every other one is here. So it means that this is the best equation for that particular question. So we need to go and use this equation for that, right? What t is here, but we are not going to be working with t. So we clean this side, and then we bring the equation. The equation is v squared is equal to u squared plus 2as. So we are looking for a, right? So we need to make a the subject, right? So if you make a the subject, so a will be equal to v squared minus u squared all over 2s, right? If you make it the subject, a will be equal to, what is v squared is 27 squared minus u squared is what, 15 squared, right? All over 2 times s is 120, right? So let's bring our calculator. So we have, so for this we are talking about 27 squared. So 27 squared minus 15 squared, right, divided by 240, because 2 times, so 240. So the answer will be equal to 2.1. So I had 2.1. So it's going to be 2.1 meters per second squared, right? So a is actually equal to, let me write the answer in another color. So 2.1 meters per second squared. Great. So we have our u already, our a already. So this question is also solved. Let's solve another one. Now they said a cyclist is moving at 5 meters per second, right? So u equals to 5 meters per second, because that's the initial velocity, and accelerates uniformly at 1.5. So a is equal to 1.5. So I'll leave the unit for now because it's not having a problem. How far will the cyclist travel in 6 seconds? So they give us t equals to 6 seconds. They say how far, that will be the distance, is equal to, they are looking for that. And what will be the final velocity? They are also looking for v, right? They are looking for both. They are looking for s, they're looking for v. So in the first case, to find s, right, let's go to this equation where let's make the best choice for the equation that we'll be using. Let me clean this around this so it will not be like that. So the first, we are looking for s. They give us u, they give us t, they give us a. So it means that this equation can go for that, right? For this part, from this particular thing, right? This equation can go for that. Okay. So to find the s, right? So this equation can go for s because we have u, we have t, we have a. So we can use this equation for that. So let's say to find S, so let's focus on S. But when you want to look for V, let's go to the equation that will use V. So when you come to V, should we use this one? Yeah, we have U, we have A, we have T. So we can use this as well. Can we use this one? We have V, we have U, we have A, but we don't have T here. But then if you find S from here, you can use that S over here, but it will be a long road. But then this and this can be used for any of them. So let's go. So for S, is equal to S will be equal to UT plus half AT squared, right? So my S will be equal to, my U is 5 times 6 plus half, where is acceleration? Acceleration A is 1.5 times T is C squared. So we will use this in the calculator. So let's say let me do this. Because of the nature of my calculator, I need to clear everything, and then let me do this side first. Let me put this side first inside. So it's C squared, right? C squared, right, times 1.5 times 0.5, because that's half, plus 5 times 6 is going to be 30, right? It's going to be 30 equal to 57. So I have 57 meters. 57 meters as the answer for this. So I'm going to have S to be equal to 57 meters. Now we need to look for V. So to look for V, we need to, let me clear this one. So we can also have space to calculate for the V. V is equal to U plus AT. So V is equal to, what is U? U is 5 plus A is 1.5 times T, which is 6. So V will be equal to, so let's bring the calculator back, clear the calculator, do 1.5 times 6, right, plus 5, so equals to 14. So you have like 14 meters per second. That will be for the V. So V is equal to 14 meters per second. So we are done with this one as well, right? Okay, so this is fine. This is equally fine. We are done solving this question. We have another question coming, right? A runner starts from rest, right? A runner starts from rest and accelerates uniformly. So it says start from rest again. So whenever we are meeting the where start from rest, we know that U equals to 0 meters per second squared. Per second, sorry. And accelerates uniformly. There's no information on the acceleration as well. After 3 seconds, so they give T equals to 3 seconds. They have traveled 80 meters, so S is equal to 80 meters. Find the acceleration. So we are going to find the acceleration A and the final velocity V. So we are going to find A and V. Okay, so we need to go to, so they're giving us distance, they're giving us T, they give us U, right? Let's look at, so we are looking for A and V, right? So for one of the equations, right, if you look at the V is equal to U plus AT. So A and V are here. So two unknowns are in the same equation. Let me use another color. So this is unknown, this is also unknown. They are all in the same equation. But see this one. The only unknown here is A, right? If you come here, the unknown here is this one and this one. So it means that we can use this one that the unknown is only one, right? Yeah, we know S, so the unknown here is only one. So we can use this equation to solve that. But if you go to the other equations first, you'll be having two unknowns and you can be solving them directly. But we are fortunate to have one that's having only one unknown. So you can use this to find just A first. When you find A, the value of A will be known. So this one it will render this equation to be having only one unknown. So you can use any of them that you want. Okay, so let's go back and then use the second equation to find the value of a. So we know that the second equation is s is equal to ut plus half at squared, right? But s is equal to, so 0 times 3 plus half a is what we are looking for, times t squared. T is what? 3 squared. So times 3 squared. But then s, we need to actually put the value of s over here. The value of s is 18, right? So it will give you 18 equals to 0. And this guy will be 0 plus half times 9. So that will be 9 over 2a, right? So you can find the value of a by just doing a is equal to 18 times 2 all over 9, right? So if you do that, you are going to have 4. The value will be 4. So the value of a, is actually 4 meters per second squared. So let me do 4 meters per second squared. So we know the value of a now. So we can go to any of the other equations to find the value of the final velocity. And among them, to me, the simplest one is the first one. But you can equally use the third one as well, right? So what do I mean by that? So if you come here, now this is not unknown. So this is known, this is known, right? So then this is also known. So now there's only one equation, one unknown in each of the equations. So what you can do is that you can go to any of them and then use this or this. So but we are going to use this because seems simple. I think over here will be maybe squaring something here, so I don't want that. So we go and use an easy life to so v is equal to u plus at. So v is equal to, what's u? U is 0 plus a is what we found, 4 times t is what? 3. So 3. At the end of the day, v is equal to 12 meters per second, right? So let me just put that one to in color here, right? So v is equal to 12 meters per second. Yeah, so that's it. Those are all the questions, all the possible questions you can find around the equations of motion, right? And by the end of after going through this, you will know how to write the parameters and use the parameters to find the appropriate equation you need to use. And then when you are done with doing that, then you can just get the equations around that. This is for linear motion. These are the various questions that we are going to solve. And I think next one we can be talking about motion, linear motion under gravity. See you in another session.